हेलो डियर स्टूडेंट्स। नैक्सट जिस तरह सानू पता है सब नू पंजाब स्कूल एजुकेशन बोर्ड दे विच +2 क्लास कैमिस्ट्री का पेपर जिहड़ा नैक्सट स्टार्ट होने जा रहा। सो उहदे लई आपां टैसट पेपर सीरीज़ जिहड़ी हैगी है सैंपल पेपर की सीरीज़ है वो स्टार्ट कर जा रहे हैं। सो सैकेंड सैंपल पेपर आपां स्टार्ट करते पे। सो लेट्स स्टार्ट फ्रॉम द फर्स्ट क्वेश्चन। सो टोटल टाइम 3 आवर का होएगा। सो क्वेश्चन दैट इज़ 1 मार्क्स के होंगे पहले 10 क्वेश्चन। सो स्टार्ट करते हैं फर्स्ट क्वेश्चन। Units of cell constant already we have discussed many times, that is a centimeter inverse. In a bimolecular reaction if one of the reactant is in excess, so एक अगर कोई भी reactant excess ਦੇ ਵਿੱਚ ਲੈ ਲੈਂਦੇ ਆ ਤਾਂ ਉਸ ਤਰ੍ਹਾਂ ਦੇ ਕਹਿੰਦਾ reaction ਨੂੰ ਆਪਾਂ ਨਾਮ ਕੀ ਦਿੰਦੇ, that is a pseudo phosphorus reaction is the name of that reaction। ठीक है। third है next IUPAC name of platinum NH3 twice Cl NO2 is, so name IUPAC name of this compound is option C, that is the diamine chlorido nitrito and platinum 2 is the right answer। So C option is the right answer। Next, the reaction of iodobenzene with copper powder in a seal tube that will give diphenyl, this is also a reaction, that is a Ullmann reaction। Next, the chemical reaction of 2HCHO plus concentrated NOH that will give CH3OH, CH3 आएगा थे, and HCH HCOONA ऑक्सीडेशन तो रिडक्शन दोनों अकरिंग हो रही हैं। ठीक है, दो अगर मॉलिक्यूल ले लेने सेम टाइप दे इन डिपेंड्स ऑफ कंसनट्रेटेड बेस that will give the reaction name of this reaction, that is a B option, Cannizzaro reaction is the name of that reaction in which the CC bond does not formation। ठीक है। next, a distinction between pentan 2 on and pentan 3 on। so this is also a that is a iodoform type test which will used to distinguish between pentan 2 and 3 on। Next, which of the following will undergo aldol condensation? So aldol condensation the key condition that molecule must have the alpha hydrogen। so right answer, that is the D option is the right answer। ठीक है। so next, the molality is expressed molality, it is defined as number of moles of solute dissolved in 1 kg of solvent। so right answer, that is the B option, mole per kg। next, which of the following is not affected by temperature? ना affected नहीं है। so the name of reaction is, that is a molality in which the volume term does not apply। so this is the main answer, that is a molality। next, a mole fraction of a solute in 2.5 molar aqueous solution। so जो ये solve करांगे, so right answer, that is a B option, 0.043। next है aldehyde and ketone react with electrophile but not with nucleophile। so this is a false statement। next, acetaldehyde can be reduced to ethane in presence of lithium aluminum hydride, this is also a false statement क्योंकि साढ़े कोल अल्कोहल फॉर्मेशन हो जाएगी। next, alcohol are more soluble in water than hydrocarbon, this is also true statement क्योंकि अल्कोहल की हाइड्रोजन बॉन्डिंग बना देंगे। ठीक है। chelate complex tend to be more stable, this is also true statement। nickel cyanide is a scarce planar complex, this is also a true statement। so this is the right answer। next, that is a paragraph based questions। ठीक है। next है 2 marks carrying question है। ठीक है। and after that there is a 3 marks carrying question and last section D, that is a 5 marks carrying question होंगे साढ़े कोल। so start करते हैं first तो, that is a second 2 marks carrying question, difference between ideal and non ideal solution। the interaction between the unlike molecules are of the same order as that of molecules। so अगर interaction between the unlike molecule are different होंगे, that is a non ideal solution। अगर similar interaction होंगे, that is a ideal solution। delta V mixing 0, ideal solution delta H mixing 0, non ideal solution delta V mixing does not 0, delta H mixing does not 0, and ideal solution each component overalls slow at all temperature and pressure, and non ideal solution do not overall slow। ठीक है। ideal solution is formed by liquid which have similar structure and polarities, non ideal solution is formed by the liquid which are structurally different or have different polarities। ठीक है। next, numerical है, that is based upon the osmotic pressure pi is equal to CRT। सानू concentration volume सारा कुछ given है, put करांगे value solve करांगे, we will get the answer। next, if first order reaction is to find to have rate constant given है, find it half life time half life period। so apply करांगे half life period दा formula, that is T half equal to 0.693 over K, rate constant है, value put करांगे solve करांगे, we will get the answer of half life period। next, Difference between the rate of reaction and reaction rate constant. So rate of reaction, it is the speed with which the reactant are converted into product, and it is measured as the rate of decrease in concentration of reactant. Reaction rate constant, it is proportionality the rate law and defined as the rate of reaction when concentration of reactant is unity. Rate of reaction depends upon the initial concentration of reactant. Reaction rate constant, it is independent upon initial concentration. Rate of reaction units are mole inverse, time inverse, and in case of reaction rate constant, units depend upon the order of reactions. Next is corrosion. Corrosion, that is it is a process of deterioration of metal as a result of the reaction with the air or water surrounding. And in case of iron, the corrosion type, that is called as a rusting. So chemical rust, the formula. Next question. So that is a Fe2O3 X water molecule, that is a chemical rust formula. Next question is article the difference between weak field and strong field ligand. In case of weak field ligand, the ligand with small value of a CFSC, so that is called as a weak field ligand. And the ligand with this large value of CFSC, that is a strong field ligand. CFSC, in case of CFSC, is less than pairing energy, weak field ligand. And in case CFSC is more than pairing energy, that is a strong field ligand. In case of pairing of electron does not take place and formed as outer orbital or low spin complex, and in case of strong field ligand, that pairing of electron takes place and formed as a inner orbital or high spin complex. In case of weak field ligand, for example, F negative Cl negative. In case of strong field ligand, that is a Co and Cn negative. Next, a write short note on coupling reaction. In case of coupling reaction, when two molecules react with each other to form a coupled reaction. So for example, when benzene diazonium chloride react with the phenol, okay, and after that there is a formation of a couple, that is a nitrogen para hydroxy azobenzene जो formation हो जाएगी. This is also called as a di formation. So this is called as a coupling reaction. Okay. Next, the use of ether. Ether, diethyl ether is an industrial solvent. It is also used as a refrigerant भी use करते हैं. It is used in surgery as an anesthetic भी use करते हैं. ठीक है. This is use of ether. Next, why carboxylic acid exists as a dimer? Again, very important question. Carboxylic acid, as we know, in case of carboxylic acid, in the structure formation, that will show the intermolecular hydrogen bonding between the molecule of carboxylic acid, that is give the large magnitude of a hydrogen bonding. Due to that, carboxylic acid in anhydrous state or when dissolved in some non-aqueous solvent exists as shown below. So this is due to the intermolecular hydrogen bonding. The hydrogen bonding is so strong and it doesn't break even the vapor phase. Why boiling point of carboxylic acid are higher than corresponding alcohol? So boiling point of carboxylic acid are higher than that of alcohol due to the magnitude of hydrogen bonding. In case of carboxylic acid, as we know, in case of carboxylic acid there is a dimer structure formation and the magnitude of hydrogen bonding is large, and in case of alcohol that also shows hydrogen bonding, but the magnitude of hydrogen bonding is less. So that's why that due to that carboxylic acid have high boiling point as corresponding to the alcohol. Next, aniline dissolve in aqueous HCl. So aniline dissolve in water due to the hydrogen bonding. In aniline, aryl group, that is a hydrophobic part nature, and due to that the size of hydrophobic group increases, hydrogen bonding and hence solubility in water decreases. Due to the large size of phenyl group aryl, the aniline is not much soluble in water. However, on addition of HCl, so ਜਦੋਂ ਵੀ addition ਕਰਦੇ हैं HCl, the aniline readily dissolve in water. It is due to the salt formation and which ionize so formed interact with the polar water molecule and hence solubility increases. ठीक है. So ਉਹਦੇ ਨਾਲ salt formation with the solubility increase कर ਜਾਂਦੀ. Next, chemical name of vitamin D, that is a arzocalciferol. So deficiency disease, that is a rickets. ठीक है. Next, why methylamine has less boiling point than methanol? So reason is that again boiling point in case of methylamine due to the less electronegativity of nitrogen than oxygen. The hydrogen bonding in alcohol is stronger, and the hydrogen bonding in alcohol becomes stronger than the amine, As such, boiling point of alcohol are larger or more than that of a amine, ठीक है, with the comparable molecular mass. Next है factor affecting the solubility of complex ion. So there are large factors which are affecting the stability of complex ion. So first, that is a charge on central metal ion. Second, size of metal ion. Third, basic strength, and size and charge of ligand. So size on the charge on the central metal ion. In general, the greater the charge density on central metal ion, greater is the stability of complex. ठीक है. Size of metal ion, as the size of metal ion decreases, solubility of complex ion increases. Basic strength, the more the basic strength, basic ligand, greater is the ease with which it can donate a lone pair of electrons. Size and charge of ligand, for anion ligand, the higher the charge, smaller is the size, the more stable is the complex. ठीक है. Next question is, why transition metal show variable oxidation state? So transition metal that will show the variable oxidation state due to the availability of n-1d and ns electron for the bond formation, as the energy of penultimate d orbital and ultimate s orbital are nearly same. So the sum total of ns and n-1d electrons determine the highest oxidation state of the transition elements. So ਇਹਦੇ ਕਰਕੇ transition elements different oxidation state show ਕਰਦੇ. Next question 15. So ਇਹਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ I value given है, time given है, so charge total charge के वो निकाल लवांगे कि O is equal to IT. ठीक है. So ਸਾਡੇ ਕੋਲ 3600 coulomb आ जाएगा. So total number of electron can be calculated by the formula Avogadro number divided by the Faraday constant multiple the amount of charge, we will get the number of electrons. So after that, there is a numerical, that is a based upon the Nernst equation. Cell representation is given, so write the at a node and oxidation half cell reduction is given, nickel to positive 2 electron. At cathode, reduction half cell reduction is written, copper to positive plus 2 electron to form copper. Then overall cell reduction, and after that the Nernst equation can be written easily. E cell become equal to E node cell, that is a E cathode minus anode, minus 0.059 over n log concentration of product over reactant. So log value अब solve करेंगे. E node cell, E node इतने nickel to positive to nickel easily calculate करेंगे by this method, and we will get the answer. ठीक है. Next है Kohler's law based numerical. Molar conductivity at infinite dilution of sodium acetate value given है, HCl दी given है, molar conductivity and infinite dilution of sodium chloride given है. So molar conductivity of acetic acid can be determined by applying 1 plus 2 minus 3 equation. So apply करेंगे ਆਪਾਂ, solve करेंगे, we will get the answer 402 Siemens centimeter square mole inverse. ठीक है. Next ਸਾਡੇ ਕੋਲ numerical again activation energy based. So ਦੇ ਵਿੱਚ ਜਿਹੜੀ rate constant ਦੇ rate constant become double हो रहा, K2 given become equal to twice, and activation energy find out करेंगे. Temperature T1 given है 298 and T2 that is a 308 Kelvin. So सारे ਦੀ value put करेंगे तो activation energy इतो solve करेंगे, we will get the answer 52.9 kilojoule per mole. ठीक है. Next है the discuss the reaction and mechanism of acidic dehydration of ethyl alcohol to prepare the ether. So dehydration of primary alcohol like ethanol with concentrated sulfuric acid at 413 Kelvin. So ਘੱਟ temperature ਤੇ ਜਦੋਂ ਵੀ heating ਕਰਦੇ ਹਾਂ alcohol ਨੂੰ, ਸਾਨੂੰ ਪਤਾ ਕਿ that will form the ether. Ether ਦੀ formation ਹੋ ਰਹੀ ਹੈ diethyl ether. So this will follow the SN2 mechanism. So first step, that is in the mechanism, the first step, that is a protonation of alcohol. Alcohol will get the H positive ion from sulfuric acid and will give the protonated alcohol. After that the removal, second step, that is the removal of water. ठीक है, removal of water हो जाएगा. So ਉਹਦੇ ਨਾਲ ਕੀ ਹੈ, दूसरे molecule ਦੇ ਉੱਤੇ attack ਕਰੇਗਾ and removal of water हो जाएगा. In the third step, formation of ether. So oxygen, the positive charge can be removed by gaining the number of electron from hydrogen bond, OH hydrogen bond. So due to that H positive released and formation of ether will occur. ठीक है. So next question है, why phenol are more acidic than alcohol? In case of phenol, as we know, phenol are more acidic than alcohol due to their resonating structures. In case of phenol, that is a resonance hybrid of these 5 structures. So due to the resonance, the oxygen acquire positive charge, and that will it will strongly attract the share pair of OH bond toward itself, and H positive ion are easily released. So due to that, a phenol that will undergo phenoxide ion, and H positive ion that will show acidic nature. Okay. Similarly, alcohol also show alkoxide ion, and H positive one that will also show acidic in nature. But which one, but the problem is that which one is a more stronger acidic. Okay. So this can be solved on the basis of a resonating structure of phenoxide ion. As we draw the structure of phenoxide ions, that will show phenoxide ion is stabilized to a greater extent due to the dispersion of a negative charge. So phenoxide ion readily formed due to the dissociation of phenol. On the other hand, an alcohol or alkoxide ion, note here, in the alkoxide ion does not show any resonating structure and electron density on oxygen in alkoxide ion, and thus the destabilize it, and it is destabilize it. So due to that, the phenoxide ion show the large stability, resonating structure, and high acidic in nature. Next question, that is a what is bromamide reaction. So Hoffman bromamide reaction. In case of Hoffman bromide reaction, when RC1H2 amide that will react with the bromine in presence of base sodium hydroxide, RNH2 amine the formation हो रही है, sodium carbonate NaBr out and water out हो रहा, so amine the formation हो रही है. This is called as a Hoffman bromamide reaction. ठीक है जी. Next, formation of benzene diazonium chloride. So from aniline that will react with the nitrous acid in presence of HCl, HONO plus HCl to form a benzene diazonium chloride is the conversion. Next, I write short on Gabriel thalamide reaction. This is also one of the important reaction for the preparation of primary amines. So pure primary amine can be obtained from alkyl halide by the method of, that is a Gabriel thalamide synthesis reaction. First of all, that is a thalamide react with the QH will give the potassium thalamide. After that, reaction with alkyl halide that will form an ethyl or an alkyl thalamide, and with the hydrolysis in acidic medium will give the phthalic acid and ethyl amine, that is a primary amine the formation हो जाएगी. ठीक है जी. So next question है, why zinc, cadmium and mercury do not have a partially filled d orbital in their states, and they are not classified as a transition metals or elements. As we know, in the zinc, cadmium and mercury, zinc has a 3d10 30 atomic number, 3d10 4s2, cadmium has 4d10 5s2, and mercury has, that is a 5d10 6s2 electronic configuration. And upon the zinc 2 positive electronic configuration, that will give the 3d10 electronic configuration, all fully filled orbitals. In case of cadmium 2 positive, that is also a 4d10 fully filled electronic configuration, and in case of mercury 2 positive 5d10, that is a fully filled electronic configuration. So due to that, they do not have a partially filled orbital in their oxidation state, and that so these are not regarded as or not classified as a transition temperature. So this is the transition elements. So this is the right answer. Okay. Next, many transition metal or their compound act as that is a good catalyst. So reason is that many transition metal and their compound are found to act as a catalyst because of the presence of incomplete d subshell, or they can form unstable intermediate product with the reactants. So for example, finely divided nickel, platinum, palladium are used as a catalyst for the hydrogenation. Second, iron ਤੇ molybdenum use करते हैं catalyst for the manufacture of ammonia in the Haber process. ठीक है, so ਉਹਦੇ ਵਿੱਚ ਵੀ use ਕਰਦੇ हैं. So this is indicate that transition metal act as a good catalyst. ठीक है. Next question है, why transition metal have high melting and boiling points? So this is due to the presence of unpaired electron in their atoms. Transition elements in general have a stronger interatomic interaction and hence stronger bonding between the atoms. So the stronger bonding between the atoms are very strong. As a result, high melting and boiling point of transition metal exist. ठीक है. Next that is a lanthanide and actinide series similarity. Say in the oxidation state, lanthanide show +3, oxidation state expected few case show +2 and +4. In case of actinide, that also show +3 oxidation state, and some will show +4, +5, +6, +7 oxidation state. Binding energy, lanthanide energy, binding energy of 4F are higher. Binding energy of 5F are lower. Shielding effect, the 4F electron have greater shielding effect, therefore the contraction in their ionic radii is less. In case of 5F electron has poor shielding effect, therefore contraction size is more. Tendency to form complex, lanthanide have tendency to form complex is less, actinide have greater tendency for the complex formation. Basic character, lanthanide compound are less basic, actinide are more basic. Tendency to form oxoines, lanthanide do not form oxoines and actinide form oxoines. Radioactivity, except promethium, these are non-radioactive, and in case of all actinide are radioactive in nature. In case of lanthanide, most of their ions are colorless, and in case of actinide, the most of actinide ions are colored. Okay. And in lanthanide, they are paramagnetic, and their magnetic properties can be easily explained. And in case of actinide, these are paramagnetic, but their magnetic property cannot be easily explained. Next step, naming reaction question, 5 marks. So first, a Walsh-Schumann reaction. So as we know that benzene diazonium chloride react with hydrofluoroboric acid, that will convert into benzene diazonium fluoroborate. Further heating with fluorobenzene conversion हो जाएगी, that is a Walsh-Schumann reaction. ठीक है. Next, Friedel-Crafts alkylation, in which the benzene react with the alkyl halide in presence of anhydrous aluminum chloride. So ਇਹਦੇ ਨਾਲ H ਤੇ ਇਥੋਂ Cl out ਹੋ ਜਾਏਗਾ, the formation ਕੀ ਹੋ ਰਿਹਾ toluene, that is a Friedel-Crafts alkylation. Next, definition of chiral, an object or a molecule which is not superimposable on mirror image, that is called as a chiral object. Example, that is a human hand. Next important naming reaction that is again Walsh-Schumann reaction. Sulfonation of a haloarine, in case of a haloarine react with the sulfuric acid concentrator, that will give ortho and a para product. ठीक है, 2-chlorobenzene sulfonic acid, 4-chlorobenzene sulfonic acid. Next, Sandmeyer reaction, in case of benzene diazonium chloride convert into chlorobenzene by using the CuCl cuprous chloride HCl. Next, that is a Finkelstein, that is a alkyl halide converted into alkyl iodide in the presence of sodium iodide in presence of acetone or reflux. In case of Schwarz reaction, when alkyl halide convert into alkyl fluoride in the presence of silver fluoride or mercurous fluoride, that will give the Schwarz reaction. Ullmann reaction, when iodobenzene, the two molecules react with the copper in presence of Cl2, will give the diphenyl. Next, SN1 and SN2 difference. So SN1, this is a substitution nucleophilic unimolecular. SN2 substitution nucleophilic bimolecular reaction. It follows first order reaction, it follows second order reaction. In SN1, it involves two steps. This is a single step mechanism. It involves formation of carbocation as intermediate. It involves the formation of transition state. It is a unimolecular backside attack. A retention of configuration exists, and here only the SN2, that is the inversion of configuration. Order for reactivity, that is a tertiary greater than secondary greater than primary, and here order of reactivity reverse. Here order is 1 and order is 2. Next, the difference between haloalkane and haloarine. In case of a haloalkane, that is a CX bond sp3, haloarine CX bond, that is sp2, that will readily undergo nucleophilic substitution reaction. It readily undergo electrophilic substitution reaction. Halogen atom in haloalkane is very reactive. Halogen atom in haloarine, that is less reactive. These are lighter than water, these are heavier than water. Haloalkane, these are soluble in water and polar in nature, these are insoluble in water. Okay. Last question, use of iodoform that can be used in pharmaceutical as a antiseptic. So it is clear that ਸਾਰੇ ਦੇ ਸਾਰੇ ਪੇਪਰ 70 ਆਊਟ ਆਫ 70 ਮਾਰਕਸ ਲੈਣ ਦੇ ਲਈ ਸਾਨੂੰ ਸਾਰਿਆਂ ਨੂੰ ਸੈਂਪਲ ਪੇਪਰ ਸਾਰੇ ਕਵਰ ਕਰਨੇ ਚਾਹੀਦੇ। ਸੋ ਸਾਰੇ ਪੇਪਰ ਕਵਰ ਕਰੋ, ਫੁੱਲ ਤਿਆਰੀ ਕਰੋ। ਸੋ all the best to all the students. Thank you.